buoyancy of various objects. And the buoyancy force is equal to the way that the fluid displaced. You know this is Archimedes' principle. The buoyancy force, again, is equal to the way that the fluid displaced. That would be the density of the fluid times gravity times the volume of the fluid. We are in a fluid, we are air. We would be heavier if we were in a vacuum. In the 19th century, they were looking for a miracle substance. That miracle substance that they found is known as water. So they defined water as one. They defined the density as the mass of the object or fluid over the volume over its volume. And the units would be kilograms per cubic meter or grams per cubic centimeter. Okay, so they defined that magic fluid as being one. So 1 gram of water occupies 1 cubic centimeter of volume. 1 gram per ml, 1 kilogram per liter, 1,000 kilograms per cubic meter. Now in this century, we also define it at a specific temperature and a specific pressure, so it isn't quite 1,000. But for calculation purposes, everybody uses 1,000, unless you're being really, really precise. So based on that, we have specific gravity is the density of the object of the fluid over the density of water. If your specific gravity is greater than 1, you will sink. If your specific gravity is less than 1, you will float. If it's equal to 1, you're just going to stay wherever someone puts you in the water. So if we look at this, we're massing the object in air. The tension in that string will be equal to the weight in air. However, if we put the mass in a beaker of water, we'll notice that the mass up here reading is different because the tension will be different. The tension then will be the weight in air minus the buoyancy force. So in that case, we calculate our specific gravity as being the mass in air over the mass in air minus the mass in the fluid.